Alright, welcome back to more content for week 4 part A. So now let's talk a little bit about comparisons. So comparisons are basically expressions that evaluate tuable type. We've already kind of seen these. So again, it's some expression of code that evaluates either true or false. There's a lot of different kinds of comparisons, and they're all going to contain some sort of relational operator. So let's talk about what these relational operators look like. So these relational operators are going to be basically the same less than, greater to, equal comparisons that you are used to from math class. So for example, again, this is assuming that these variables x and y both have some. Generally, they're going to be a numerical type, though technically it can work with strings, but it's a little bit weird about strings. So for this class, though, we're mostly just going to talk about if x and y are numerical types. So for example, x less than y, this is going to be true if x is strictly less than y, right? To do less than or equal to, you do a less than symbol and then an equal sign. So x less than equal y, that will give you a true if x is less than or equal to y. And then of course you have the same thing for greater than. So one way that I sort of keep track which one is less than, which one's greater than, is if you look at the sign, the less than and greater than sign, as if it's the side of like an alligator's mouth. Right? And the alligator is going to want to eat the bigger thing. That's how I keep them. That's how I memorize them. Do what works for you, though. But again, these are the same, less than, greater than symbols as, a typical math class. The only thing that might be slightly new / different is how you represent less than and equal to, or greater than and equal to. You just do the less than or greater than, and then followed immediately by an equal sign. And again, these all will evaluate to some bool type, either true or false. Alright, so just some practice. If I type this code, print 10 less than 11, what are we going to get? That's true, right? So again, these are going to evaluate to either true or false, and it is true that 10 is less than 11, so this one will come out as true. Alright, what about this one? Negative 10, less than or equal to 10. That one's also true, right? Negative 10, definitely less than or equal to 10. Alright, how about this one? 10 greater than 10. That one's going to be false, right? So this one is strictly greater than, so this one will only be true if 10 is strictly greater than 10, which clearly that's not the case, right? 10 and 10, that's the same. So this is going to come out as false. On the other hand, this one, greater than or equal to, this will come out as true, right? Because 10 is indeed equal to 10. Alright, not too bad, right? Alright, the last comparisons that I want to talk about, which might look a little bit weird, is checking to see if they're equal or not equal. So to check and see if these two numbers are going to be equal, or maybe two strings are equal, something like that, you do the two things that you're checking, and then in between them you put two equations, two equal signs. So this will give you true if x and y are equal. Something that I do want to point out about this is different than just a single equal sign, right? This comparison has two equal sign, it has the double equal sign here. This is different than a single equal sign. Remember, with the single equal sign, we are doing an assignment statement. So be really careful about these comparisons. Double equal sign is checking to see if they're equal. A single equal sign is the straight up assignment statement, putting something on the right hand side into the variable on the left hand side. So be careful about doing these equal to comparisons. Make sure you have the correct number of equal signs. And then to check and see if something is not equal to something else, you do that exclamation point equal sign. So again, we talked really briefly at the very beginning of the quarter when I said CS does not equal programming, and we use this syntax here. So again, to check to see if something is not equal, it's exclamation point equal sign. The exclamation point basically means not. Alright, so just a couple more examples to run through together just to make sure this all makes sense. Alright, so print 10 equals 11. That's going to be false, right? So again, this is checking to see if they are equal because there are two equal signs. Clearly, 10 does not equal 11, so if you're saying, hey, does 10 equal 11? No, it does not, so it's false. This one, on the other hand, is checking to see if 10 does not equal 11. Now, 10 does not equal 11, right? So this is going to be true. So this one's a little bit backwards, right? This is true if they're not equal to each other. Alright, what about this one? 10 equals 11. So this is going to give you an error message. Alright, so this goes back to the idea of that single equal sign. That is trying to do an assignment statement, and it doesn't really make sense to do this assignment statement because the name of the variable on the left-hand side is not a legit variable name. So again, be really, really careful with these comparisons. If you're checking to see if two things are equal, make sure you use double equals. If you use single equals, Python's going to think that you're trying to do an assignment statement, a variable assignment statement. One last thing I do want to mention about these comparisons is if you combine any of these comparisons, meaning the less than, greater than, equal, all that kind of stuff, and bool operators, so the bool operators were the things that we talked about before, the and, or not, you should evaluate the comparisons first. Alright, so you should evaluate the less than, equal, greater than, all those things, evaluate those first. Alright, so this is kind of order of operations with Boolean stuff. You do the comparisons first. So if you had code that said not A equals B, that means you first check and see A equals B, check and see if A and B are equal to each other first, and then you apply not to the whole thing. So again, do the comparisons first. Alright, couple of examples just to run through. So go ahead, pause this video, and write these out on paper, and come back when you are ready to check your results. Alright, so hopefully you ran through this. Going through these one at a time. This first one, you get true. Next one will be false, true, and true. Let's briefly go through these together, just to make sure we're all on the same page. So let's talk about this first one. We have, let's see, we have 10 not equal to 11 and 4 less than 5. So remember, the rule with these is you want to do the comparisons first, meaning we're going to do this and this first. So let's talk about the first one. 10 not equal to 11. That's true, right? 10 does not equal 11. So this is true. And then the one on the right-hand side, 4 less than 5, that's also true, right? 4 is less than 5. So that means we have true and true. Again, the rule is with and, if both of them are true, whole thing's going to be true. So this will give us a true back. That's this true here. Let's do this next one together. So we have 10 equals 11 and 4 less than 5. So again, same thing. Do these comparisons first. 10 equals 11. That's going to be false. This is still true. We have false and true. Again, the rule is with and, they both need to be true for the whole thing to be true. So this is going to be false because that first one is false. So we get false right here. Alright, next one. Next one is 10 not equal to 11 or 4 less than 5. Again, comparisons first. We already know this whole thing is true. This one is also true. So we have true or true. With or, if they're both true, whole thing is true. Alright, last one. 10 equals equals 11, or 4 less than 5. Again, comparisons first. We've already done these comparisons, so we know this is false. We know this is true. So we have false or true. Now again, the rule is with or, only one of them has to be true with or for the whole thing to be true. So false or true, since this one is true, whole thing's going to be true. So that one comes out to true. If you have any questions about these examples, as usual, feel free to post the discussion forum or send me an email if you'd like.